Welcome, calculus students, to your first lesson on YouTube. Flange here, ready to go. I want to tell you there's a lot of stuff in this first section, but it's all review. And it's basically the idea of solving equations, going from the easier linear equations up to the trickier ones involving radicals and powers and absolute values. So I'm going to kind of review each of the kinds and some of the theory behind all of them, and we'll do a lot more examples in class. So here goes. Solving linear equations in one variable and equations that lead to linear equations. So that's stuff like this. And what do they mean by equations that lead to linear equations? Well, solving a linear equation in one variable, 2x plus 3 2x plus 3 equals 8. You've seen those before. You subtract the 3 from both sides and then divide by 2. And of course it can get more complicated with more grouping symbols and so forth. But what if an equation that leads to linear equations, it might look like a quadratic, like x plus 2 squared equals x minus 3 squared. Well, when you expand this, you get x squared plus 4x plus 4 equals x squared minus 6x plus 9. And now we see that the squaring parts cancel out. So that you really only have a linear equation now. We add 6x to both sides to get 10x plus 4 equals 9. Subtract the 4 from both sides to get 10x equals 5. And so x equals 5 tenths, which is 1/2. Okay? Now, come back to this equation again, because maybe you see another easier way to maybe deal with this equation by taking the square root. If you take the square root of this right away, though, something strange happens. Let's bring out a red pen for strange. If you take the square root of both sides, and you end up with x plus 2 equals x minus 3, 2 equals negative 3. What? Turns out, when you take the square root of this, though, you actually get the absolute value. And what we actually have to consider, too, is the case of x plus 2 equals the opposite of x minus 3. So x plus 2 equals negative x plus 3. So 2x equals 1, and again, you get x equals 1/2. So sometimes you got to watch out for what you think might be a shortcut. And we'll talk more about this theory of why this generates 2 possible answers in a later page. Let's get to that page. Oops, backed up. We go forward. Here we go. Solving quadratic equations by factoring, extracting square roots, completing the square, and using the quadratic formula. 4 ways you can use to solve a quadratic equation. Well, factoring, let's start with this. Let's start with factoring. Factoring is when you can easily factor it, like x squared plus 5x plus 6 equals 0. And you can see that that factors into x times x, and factors of 6 add up to 5. That's 2 and 3. So you get x plus 2 equals 0, x plus 3 equals 0, x equals negative 2, x equals negative 3. Great. Well, factoring is a nice fast technique if you can see how to factor it, and you can actually turn even higher degree equations into a series of linear equations. But what do we do if it doesn't look factored? Well, extracting the square root comes up next. Let's take a look at some of those. Extracting square roots. That's like you've got x squared equals 9. And see, you've got a case here where you had a squaring term, but no x term to worry about. So you can actually take the square root of both sides. A lot of students mistakenly think you can take the square root of both sides on this, but you can't distribute the square rooting over these addition signs. So over here, though, you can take the square root of both sides. That actually leads to the absolute value of x equals 3, and we get plus or minus 3. Okay? You could have also done this one by factoring, by saying x squared minus 9 equals 0, and then factored x plus 3 times x minus 3. But this is considered a faster technique. And of course, it doesn't have to just be an x. You could do x minus 5 quantity squared equals 7. It's a different kind of problem now. I mean, well, it's the same kind of problem, but a little more complicated there. Now when you take the square root of both sides, equals the square root of 7. Now you can see that you get absolute value of x minus 5 equals the square root of 7. So x minus 5 equals plus or minus the square root of 7. And x equals 5 plus or minus the square root of 7. Okay? Now, this whole extracting square roots technique is a little like completing the square. And let me pop in a little page here so we can talk just about this idea of completing the square. Completing the square is all about adding just the right something to turn your polynomial into a perfect square. So when you've got something like x squared plus 4x plus 2 equals 0, well, that doesn't quite factor. Factors of 2 are 1 and 2, and those add up to 4. But if we just keep the x squared part and the 4x part, put a little blank here, let's put the negative 2 on the other side. There's our blankety blank there. We can add just that certain something to both sides so that the square is completed. This is not a perfect square. But if we take half this term, 4 divided by 2 equals 2, and then square that, add that to both sides, now this is a perfect square. The square of what, though? This side is 2. What's this side the square of? Well, x got squared to get that. 2 got squared to get 4. And when you expand out x plus 2 quantity squared, remember that middle is twice the 2 ends, so you get the x plus 2 quantity squared. So that leads to x plus 2. Now it's like a problem just like extracting a square root. X plus 2 equals plus or minus the square root of 2. So x equals negative 2 plus or minus the square root of 2. Now our last technique then is quadratic formula for how do you solve a quadratic. And again, let me pop another page here. Quadratic formula. I'm sure you all remember it. If you have ax squared plus bx plus c equals 0. If you have a hard time remembering it, I'm going to share a little song with you. I'm only going to sing this once, people. You ready? It goes to the tune of Pop the Weasel. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There you go. Now you got no excuses. You got a song with it and everything, people. You can prove this with completing the square. Somebody wants to try and take that on, I'd be happy to add that to the notes. It's a great little proof. I can help you with it. And the quadratic formula, a lot of kids like it because, you know, it always works. True, but all the other things we looked at before are simpler. And also, it's not so easy because this section right here, this b squared minus 4ac, you always have to watch out for that because that could simplify down. You might be able to get a perfect square out and so forth. Okay. Well, got to move on. We'll do more examples of that in class if you're having a hard time solving your complete quadratic formulas. Now, solving polynomial equations to degree 3 or greater, well, that's just a matter of factoring usually. There's no other tricks involved here other than just plain factoring. So if you've got x cubed minus 4x equals 0, you can factor out an x times x squared minus 4 equals 0, and then the x squared minus 4 is the difference of squares, so that's x minus 2 times x plus 2. And then you can set each factor equal to 0, or x minus 2 equals 0, or x plus 2 equals 0. And look at that, we get three answers. 0, 2, or negative 2. Okay? All right. Solving equations involving radicals. Oh, I did want to say one thing. I should back up a page. Back up a page. There we go. Third degree equation. 3 answers. You can use that in checking your polynomial equations of higher degree there. Solving equations with radicals, you just sort of undo the radical. Square root of x equals 5. So how you undo a square root? With squaring. Square both sides. X equals 25. If you've got something like a cube root, if you've got something like a cube root, let me extend the page. Cube root of x equals negative 3, you could cube both sides. So x equals negative 27. Okay? And that's how we deal with radicals. Finally, equations with absolute values. We actually solved some of these before as part of the whole extracting the square root technique. And that's the idea that if you've got the absolute value of x minus 3 equals 5, you can think of that as x minus 3 equals plus or minus 5. So x equals 3 plus or minus 5. So you get 3 plus 5, or you get x equals 3 minus 5. So x equals 8, or x equals negative 2. Those are the two answers now. Even though it looks like a linear equation, the absolute value has done something to it here. And let me demonstrate that with a little diagram here. Absolute value of x minus 3 equals 5. Why does a seemingly linear equation give us two answers? Well, let's think about it visually. Y equals the absolute value of x minus 3 is actually a V. It's not a line. It's a broken line, like that. Okay? And y equals 5, the other thing here, y equals 5 is just a horizontal line, going like this. So the two cross in two spots. In the two spots, a negative answer and a positive answer, sure enough, are negative answer and positive answer of negative 2 and positive 8. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8, and positive 8. That's where they cross. So that's a kind of visual reason why you get that. Another thought process on this is to think of this in terms of the distance formula. Absolute value of x minus 3 equals 5 can be translated into the distance from x to 3 is 5. So, you don't know where x is, but you know where 3 is. And you know x is 5 away from 3. So, 1, 2, 3, 4, 5. There's 8. And back up 5. 1, 2, 3, 4, 5. There's negative 2. See how we went 5 in each direction. And there are your two answers. Okay, I believe that's it. Solve equation with radicals. We did that with absolute values. Yeah. Oh, we keep hitting the wrong button there. There we go. Okay, so flange out.